In this video, homework problem number 5, we will show how the moment of inertia about the centroidal x-axis is arrived at. The first thing we want to do is, of course, identify where the centroidal x-axis is. In this case, because it's a symmetrical shape, we know that the x-axis lies halfway up through the shape. We will then break our shape down into standard shapes that we know how to deal with. That is the large 6x6 square and then the smaller 4x4 foot hole. After doing this, we will focus on the large 6x6 square. The moment of inertia about the centroidal axis for this large square is derived from the equation 1/12 pace times height cubed, or 1/12 6 times 6 cubed. That gives us 108 feet to the fourth. The area, of course, is 36. That's simply 6 by 6. The d distance is 0. The reason why d is 0 is when you look at the centroidal x-axis for the 6 by 6 square, and then you look at the centroidal x-axis for the complete shape, those two axes lie on top of one another. They're in the same place. There is no distance between them. Therefore, d is 0. AD squared is, of course, 0. And then IX plus AD squared gives us 108 feet to the fourth. For the 4x4 hole, again, we do essentially the same thing. The moment of inertia about the 4x4 hole, about its x-axis, is 1/12 4 times 4 cubed. We have to treat this, since it's a hole being cut out of the larger shape, as a negative. So that's why you see negative 21.33. The area is 16, but again, we treat that as a negative. All right. As we saw with the larger 6x6 square, this smaller hole, its x-centroidal axis lies in exactly the same spot as the x-axis for the complete shape. So there is no distance between them. D is 0, AD squared is 0, and IX total is IX centroid plus AD squared, again negative 21.33. We then add up this last column, and we find out that the moment of inertia about the centroidal x-axis for this shape is 86.67 feet to the fourth.